Okay, I think we're ready. So many of you may know me, but my name is Jeff Morgan. I'm a principal at Hassel in our Sydney studio, and I'm chair of the MECLA's Aluminium Working Group. I'd like to begin today by acknowledging the traditional custodians of the land on which I am today and pay my respects to their elders past and present. I extend that respect to any Aboriginal or Torres Strait Islander peoples that may be here today with us. As you can see on the screen, we are holding the second of 3 deep dive sessions with key components of the construction and aluminium ecosystem over the next several weeks. Our final session will be with owners and developers, a very important group of people who often set our briefs and targets for the projects we work on. The purpose today is really twofold. Firstly, we'd like to share our working group's knowledge gained over the past year and a half of engagement, research, and discussion. And secondly, to hear from you about what your experiences, concerns, thoughts, or otherwise may be. And this includes our working group members also on the call. You may be aware, but the discussion around embodied carbon in concrete and steel is really, I think, much more advanced and well known as a topic, but aluminium really much less so. As an industry, we often seek competitive advantage, quite often against each other, but I think the challenge here is really significant and the impact's even greater if we don't address it. So I really ask you all to join today's session and discussion with an open sense of generosity and collaboration, an approach that I've kind of openly pinched from Karen Coker at ARAP. I'm sure there'll be many different points of views and opinions hopefully expressed here today, or at least I hope so, and that's really okay. Today is about hearing and learning from each other on a topic that I'm sure we can all agree is an important challenge to address. 3 weeks ago, we held our first deep dive with many of the main contractors and facade subcontractors to get a better understanding of their own experience and insights into the issue. It was a really great session, and we're looking forward to sharing some of those insights with you here today that I think you'll find really both interesting and very helpful. And today we have an excellent cross-section of our various consultancies from architecture, facades, and ESD consultancies. I'm really pleased that so many of you have accepted to attend today's session and hope that you really all get something out of it. I know the invite has been circulating around, so please don't be offended if you don't see your logo on the screen today. So MECLA was founded in April of 2021 to address the issue of embodied carbon in the built environment. MECLA is all about collaboration across the entirety of the supply chain to find solutions quickly. Currently, MECLA has over 140 members and counting, and our purpose is to accelerate the decarbonization of the construction sector. By pooling knowledge and expertise from across the supply chain, we can speed up decarbonization in these hard-to-abate industries. Importantly, MECLA does not tolerate any anti-competitive behavior, so if you are aware of any conflict of interest, please speak up so that we may adjust our actions accordingly. I think the format today will be fairly simple. I have some material prepared to run through that gives an overview of the topic and highlights some of the key points from our MECLA publication on low carbon aluminium. This is really sort of sets the scene for the opportunities and challenge in our Australian context. We'll then look at some of the recent shifts and developments in Australia, including some exciting announcements just last week from our working group member, Caprol. The last 3 items on the list are really a series of prompts for discussion on the topics of procurement, supply chain, modern slavery, and cost. And to wrap up, we'll hopefully leave you with something a bit thought-provoking perspective on what this kind of all means in the bigger picture. So I know these events can be kind of challenging to unmute yourself, but I would really appreciate it if we could have some good, robust conversations at the end of all of this. So please feel free to participate. My own journey with aluminium started just over 12 years ago. I was working at Foster & Partners at the time on Masdar, a visionary sustainable master plan city for just over 40,000 people in Abu Dhabi. There were many amazing and interesting things that came out of Masdar, but one that I think really stuck with me was the fact that the project became the first in the world to use recycled aluminium for its structural facade extrusions. Prior to this, recycled aluminium had really only ever been used in sheet or panel cladding. As a large owner and developer, Masdar used its own ambitions and influence to attract like-minded companies to push their own bounds. In this case, Alcan, now owned by Rio Tinto, teamed up with a small remelt partner in Europe to develop the particular strength alloy that they needed for the facade extrusions. So that was 12 years ago. And I suppose recently in my own work with Stockland on 110 Walker Street, I found myself asking engineers and contractors in the industry about the possibility of using recycled or low carbon aluminium in the facades. And really, to my surprise, I found the conversation or opportunity was not as I thought it would be. Something that I thought would have advanced substantially in the 12 or plus years, really apparently had not. And I think that really ultimately led me to MECLA, where over the past year and a half, we've assembled a broad range of companies that form a part of our aluminium ecosystem, including engineers, architects, LCA consultants, miners, recyclers, remelters, researchers, and financiers, and many others. And we're really all trying to get a better understanding of what the challenges and opportunities for a low carbon aluminium future in Australia are. The group has had contributions, as I mentioned, from a broad number of people and companies over that time, but I really like to just highlight a few in particular that have been really integral to the part of the journey, including um, Matthew Finn from Arup, Kiara Kenny from Lendlease, who's now relocated overseas to London, Josh Applebloom from Rio Tinto, Michael O'Keefe and Brendan Orth from Capital, who are on the call with us today, Blaze Porter from Sims Metal, that's Australia's largest metal collector and manager. Sebastian Lowenstein from the CEFC, that's a government financing body. Chris McClung from Western Aluminium and Clive Fleming from Reclaim PV. There probably really are too many others to share that have also contributed and continue to share an interest in this topic, but I'd also like to acknowledge their value to the group's journey along the way. So what have we been doing? I think since our inception, we've held 2 spotlight events with key experts on the topic, which are available also for viewing from the MECLA website. And secondly, we recently published earlier this year a resource, a MECLA resource on aluminium for the development and construction industry, which is now available also for download. This is, I guess, really just a short 10-pager focused on the Australian context, and I think really acts as a primer for everyone in the development and construction industry to begin the kind of conversations we need to have around our ambitions for a low carbon future. I'll now give a brief overview of that document, which will hopefully set the scene for the rest of the session. Before I go forward, are there any questions or thoughts before I carry on? Okay. So globally, Australia is really a very large player in the aluminium market. Um, Many of you may know that virgin aluminium is made by extracting bauxite from the earth. We then refine this into alumina, which is a white powdery substance, which is finally then smelted into aluminium. As you can see on the image above, Australia is the world's largest bauxite producer and the world's largest alumina exporter. Yet we're only the 6th largest producer of aluminium globally. And we'll probably, I guess we'll come back to this a bit later, but I think it's fair to say that there is a real opportunity locally for Australia to, in its own low carbon future. So why are we talking about embodied carbon of aluminium? Typically, aluminium is the 3rd largest contributor to a building's embodied carbon footprint after concrete and steel. And compared to other primary materials used in construction, it is by far the most carbon intensive, roughly 100 times more intense than concrete. So as you can see on the graph, for each ton of aluminium produced, approximately 14 to 20 tons of CO2 are emitted into our atmosphere. So why exactly is this? I think this picture probably gives it away. There are a few challenges around producing low carbon aluminium, the first being that it takes an enormous amount of energy to make it. To give you an example, here in Australia, there are 4 aluminium smelters along our east coast. These 4 smelters consume nearly 10% of the national electricity grid capacity alone. That figure, for me really blew me away, and I think just really puts into perspective the amazing amount of energy needed to make this material that we all know and love. In Australia, the vast majority of this energy currently comes from our coal-fired power stations. Yes, thankfully our grid is decarbonizing, but just how fast I think really remains to be seen. Our two largest smelters at Tomago in New South Wales and Boyne in Queensland have outlined plans for large-scale renewables to power these massive industrial precincts, and we'll touch on that again a little bit more later. The other challenge is probably a little bit more complicated. As many of you may know, the majority of the large-scale buildings and even medium-scale projects that we work on have their facades procured from overseas in places like Southeast Asia or China. Over the past few decades, Australia has really lost a very large, significant proportion of our manufacturing capacity and capability as a result of our current view that cost really outweighs all other metrics. So the question is, even if we made our own low carbon aluminium up the road in New South Wales, how much of it would actually make its way into our built environment? And finally, the last challenge I think is really ourselves as a development and construction industry. I mentioned earlier that advances and opportunities in carbon and steel, for example, are much more broadly known. But I think the conversation around aluminium, like the one we're having today, is really just the beginning, and we really have some way to catch up. But now, I guess for the good news, many of you will know that aluminium is infinitely recyclable. In our document, we have also outlined the opportunities for advancing a low carbon future, and there really is huge opportunity here. However, currently the linear economy does dominate the Australian value chain in aluminium. We extract more bauxite than anyone in the world, and we export it. We produce more alumina than anyone in the world, and we export it. We do, however, import nearly as much aluminium as we produce, ironically. And then at the end of its initial use, you guessed it, we export it again, approximately 95% of it overseas. So one of the great opportunities is that recycled aluminium really only requires 5% of the energy needed to make its virgin aluminium counterpart. Certified recycled aluminium alloys are the technical equivalent of their virgin counterparts, exhibiting the same strength properties and finishing characteristics. And despite the rumors floating out there that you may have heard, it can be anodized if the quality of the product is carefully controlled and certified. I think the other fantastic opportunity is that an estimated of 75% of all aluminium ever produced is still in use, waiting for recovery, recycling, and reuse. Again, an important opportunity as we transition to the circular economy model. I'm sure that, in the construction sector, the recovery of material from our demolished buildings is more mature than it has been in maybe more recent times. But I think there are really still some advancements we can make, particularly for the way that we design for disassembly, or even consider the ownership models of our buildings and assets. So this brings us to our first case study, a case study from Lendlease. Unfortunately, they were unable to attend today, but I'll do my best to take you through. This was presented 3 weeks ago from a couple of colleagues from Lendlease at our spotlight, initially at our spotlight at Aluminium, but then also with our main contractors and facade subcontractors. Like I said, unfortunately, they couldn't be there today, but I think it really does demonstrate the kind of the trials and tribulations they went through, but ultimately the successes that they found. So Lendlease's Mission Zero is really an industry-leading and astonishing commitment. They have set ambitious science-based reduction targets to be a 1.5 degree aligned company. And I guess this means that by 2025, they will be net zero carbon, meaning that they will reduce their emissions as far as possible, with the remainder to be offset. And by 2040, they will be absolute zero. So no emissions from their business activities and no offsets from their scope 1, 2, and 3 emissions. The project itself was designed by Renzo Piano and known as the Waterman's Residences, the third tower at One Sydney Harbour. It will be the first building in Australia to use low carbon aluminium for its facades. And this 30-story building will house approximately 212 luxury apartments, and it is anticipated to be complete in 2024. I think their commitment to Mission Zero was really the catalyst for looking at the impact of aluminium in their projects, not just this one. They knew that from their own benchmarking and analysis that a building's facade, and particularly the aluminium within it, is typically the third largest contributor to their building's embodied carbon. Their work began with an initial market scan of some of the known options for low carbon aluminium, which were were also able to provide verified EPDs for their products. And when they plugged this data in from their suppliers' EPDs, it really demonstrated significant savings of between 34 to 50% based on the benchmark bow building, something that was obviously really worth pursuing. One of the key findings from this process was the importance of early supply chain engagement and persistence. As you can see, the team at Lend-Lease began their journey by including a requirement for low carbon aluminium in their specification and early tender conversations. And they suggested some known suppliers to their facade subcontractors. Knowing that their colleagues in the UK had successfully implemented low carbon aluminium in their overseas projects, they reached out to see what learnings or connections may be of benefit. But it turns out it just wasn't as simple as using the same product or even the same procurement route from the UK project teams. The team in Australia then here refined the questions to ask more broadly about sustainable technologies rather than about specific products or suppliers, which led one facade contractor to find low carbon aluminium existing in one of their all currently existing supply chains. So not only was that billet ASI certified, which we'll touch on a little bit later, but it also came with an EPD, and it was able to be sourced to meet the project's program and the budget requirements. Eventually, an agreement was made for preferential sourcing of the material, and I think, as Lend-Lease said, the rest was history. Now, I guess that was really an incredibly reduced account of the work that went into successfully, sourcing low carbon aluminium for the facades. But I think it speaks to the key messages that really led to their success. First is engagement. We all need to acknowledge that this is possible, but only if we begin our conversations early and often. It may not come off for the next project or the one after, but I think like Lend-Lease, just in time for Tower 3. Interestingly, when they initially asked the question on Tower 1, they were told by the facade subcontractor that the cost of the entire facade package would be double. So not just the cost of the raw material itself, but the entire facade package would be double. And obviously that didn't stand a chance. When they asked the same question a year or so later for the second tower, the premium had come down to roughly 50%, but still extremely cost prohibitive. But by the procurement of the third tower, they had found a product. They had helped their own supplier find a product in their existing supply chain that was not cost prohibitive. In fact, Lend-Lease mentioned in the last session, and this really gave me great joy, that the cost uplift didn't even affect the bottom line. So I think, in the words of Vince or Michael, you wouldn't even think about it, which was really great to hear. I think this is something that also came up from our other contractors on the call. Built, who are building the Atlassian Tower, they were investigating opportunities for aluminium in their facades. But like Lend-Lease, they were doing this for the first time. They found the responses back from the market too cost prohibitive. But I think this is really just because the questions are being asked of our supply chains really for the first time ever. And, I'm sure we all have similar stories of trying to do something for the first time. So that point of persistence is really important. So just because you may not find the answer you're looking for at the first corner, don't let that stop you. As highlighted, it's never going to be easy to do something for the first time, but don't let that challenge be the obstacle. And finally, and perhaps a bit more specifically, make the questions we ask of our supply chains specific, clear, but also built for collaboration. In other words, nominating a specific product may not be the best way forward. So before we move on to our next topic, I thought I might just pause there for a moment to see if there are any questions or thoughts from anyone on any of the content so far.
Is it possible to share who that facade supplier was on that residential tower?
Yes, it was Perma-Steliza. So Perma-Steliza coming out of Southeast Asia. It's really unfortunate we weren't able to have them today. They're much more knowledgeable than I am on the topic, but the amount of information that they shared with the other main contractors and facade subcontractors was really quite amazing and really helpful.
Well, just know that they have a hard time competing with China suppliers.
And I think that, yeah. Go ahead.
And the money bottom line is the problem that we
Someone
fight.
else?
Go ahead.
Yeah, was someone else going to mention something?
Do you know where the aluminium's coming from? Like which supplier of aluminium?
Yeah, so this is coming from Rusal. So this particular aluminium is coming out of Russia, which was a bit of a sticking point. So they procured the aluminium was fully procured and on site prior to the invasion. So they had already actually paid for and received shipment of the product. So there was no kind of time to send it back. They are obviously pursuing other suppliers and other smelters at the moment, but yeah, this particular one came from Rusal. And I'm not sure who made the call around cost, but yeah, that is obviously a major issue. Not just cost of the aluminium itself, but cost being the primary driver for basically everything we do up until now. We had G. James, Australia's largest facade subcontractor, participating with the MECLA's group, and that was exactly their feedback and their frustration is that their kind of share of the market had been driven down and down over the past decades because of the view that cost kind of ruled all, and when it just came down to that, they really found it hard to compete and were, I guess, a bit disillusioned, to be quite open about it.
Well, I saw the Mycos logo, and Mycos are another homeboy facade supplier, and they have trouble competing with that China source. In fact, the way they compete is to get a lot of their fabrication out of China now, whereas it used to be all here in Australia. And
Yep.
they've been reduced to supplying primarily to just the residential market, which is why I was curious if they had been on that residential tower. They've been pushed out of the commercial supply market because of China, and Perma still fight very hard to stay in that game.
Jeff, Michael O'Keefe here from Capital.
Mm-hmm.
I guess it's important to separate the two areas of this discussion. The Rusal metal that Perma would have used would have been hydro-fired, and the metal that's coming out of China is black or brown coal fired for the smelting process. So the difference between the premiums in those two metals on the LME is extremely small. The big area that the gentleman's raising around my costs, for example, is the cost of labour in Asia for manufacturing of prefabricated products, curtain wall products being into Australia. It's has very little to do with the primary aluminium input or billet input. In fact, the Chinese smelters without sulfur filters are emitting in excess of 20 to 22 tonnes of CO2 emissions per tonne of aluminium, whereas that primary billet from Rusal being hydro-fired would have been 3 or 4 tonnes of CO2 emissions. So you have to do the math on the carbon emissions against the math of the labour. And I'm not at all dismissing the cost of that facade in the building, but there has to be a levelling of that understanding going forward.
This is a topic that was really discussed extensively in our working group. So we had Sebastian, I mentioned Lowenstein from the CEFC. So that's the Clean Energy Finance Corporation, and they're a federal government body that look at funding billions of dollars worth of projects and initiatives in the kind of clean energy sector. And so they were really interested in aluminium. He was incredibly helpful, and I think a lot of what he was talking about as a financier was around transparency of supply chains and modern slavery. And he said not just the CEFC, but I think increasingly, probably not quick enough, but I think it is changing more. It will be changing more quickly as corporations and other bodies are being required to report on their issues around modern slavery. And this modern slavery happens everywhere. It's important to acknowledge that it happens in Australia and it happens all around the world. But when other metrics other than cost, like sustainability, like carbon, like human welfare and environment, come into the metrics that corporations are having to report on, I think we will start to see a shift in that, because Sebastian was really open and saying, look, we won't, unless we know these things, we won't sort of finance the project.
Can I just ask about the metal from Russia? That was, processed from raw bauxite, or was it largely, did it have a recycled content as well?
No, I think this is just virgin aluminium.
It's
Yeah.
primary. Yeah, it's
Yep,
primary
yep.
primary billet. Primary billet,
Yep.
but it uses predominantly Rusal would use hydropower to
Yep.
fire their smelter, and
Yeah,
in some
Yep.
cases nuclear power. But it's primary billet, so there's very little
Yep.
very little recycled content in that primary billet.
They probably imported their bauxite or alumina from Australia.
No doubt.
Yeah, right. And is there anyone in the world kind of producing commercial aluminium for curtain walls and windows that's got a big recycled content?
Yes, hydro. We'll touch on that coming up.
Okay.
Yep.
Yeah. But feel free to ask a bit more questions around that later. But yes, there are. Yeah.
Isn't the reality of recycled content that there's the demand for aluminium is way higher than the amount of recycled content coming into the supply chain? So
Yeah.
it
Yep.
can't really. It's definitely a solution, but it's not one that's available to everybody.
No,
yeah.
that's right.
Yeah.
Go ahead,
and
Michael.
It's a complex discussion, that one, because you have to consider post-production scrap, where you can retain the alloy integrity, as Jeff was saying before, in relation to anodizing and structural alloys, versus post-consumer scrap, which is the big focus in China at the moment. But of course, with post-consumer scrap comes a lot of decontamination requirements and a lot of contamination of the billet or the log or the casting or the slab. So at this point in time, a lot of recycled content doesn't find its way into the built environment, where primary billet's preferred for its structural integrity versus the recycled content you might get in, say, a car door or an automotive part that doesn't have the same requirements around purity of the alloy. But it's a big issue, and the recycled side of things. And someone mentioned it before, about 95% of Australia's scrap goes offshore, simply because we don't yet have enough remelt facility in place to be able to capture that and feed that back into our primary material.
I think this is something. Oh yeah, go for it, Tony.
Sorry, just a quick one.
Yep.
So in the case of needing to heavily decontaminate the recovered scrap, is that 5% value of the energy input for the aluminium, does it still stack up? Does it still stand? Or is it a little bit higher?
Yeah, no, the energy side of things really stacks up. It often comes down to the commercials, and Blaze would be a great one to add to this, but it often comes down to the commercials, because remelting of aluminium, if they can get into the mid-90s as a recovery. So if you look at it from a commercial terms, they would buy that post-production scrap of, say, a percentage of LME. They would then remelt it. If they can get a high enough recovery, then the ROI stacks up, and they'll start to go down that path. But when you have to start to decontaminate the silicons and the seals and the rubbers and the paints out of, and the powder coats out of aluminium, your recovery through the remelt process drops below the 90s, so it starts to not stack up commercially. So there's a bit of work to be done in that space yet, but it's, as someone mentioned before, it's a massive opportunity. If you just consider the Capral, by way of example, Capral has post-production scrap, so that's pure primary metal that goes into a recycled cycle, in excess of 15,000 tonnes per annum. That's post-production scrap. That's not even before we start to talk about post-consumer scrap. So there's a huge opportunity, and Capral only one extruder of many extruders in Australia. So the opportunity is enormous going forward. And when you consider the 5% of energy required to put that back into the system and create aluminium, it's a huge saving potential for the environment.
So you're saying one of the barriers to this is the paints and the silicons and the things that are stuck to the aluminium, like cleaning that off.
Powder coats.
That's one of the barriers.
Powder coats, paints, all that sort of stuff.
Yeah, I mean, initially it's the required, I guess, investment around Australia to introduce enough remelt facilities to accommodate all our scrap, and B, it's just getting that sorting and decontaminating of that scrap into a position that Jeff mentioned, maybe windows designed or curtain walls designed for circularity, where they do go into the recycled process, into that circular economy, and they've been designed so they don't carry too much in the way of pollutants or contaminants. Therefore, the remelt facilities are going to get a much higher yield out of that remelt process. So then the whole circular economy really starts to come into play. So yes, that has.
I wanted to ask
role
about that.
play.
Yeah, whether MECLA is doing any work, or anyone else for that matter, in informing the way that we design to make it more recoverable with it and reduce that decontamination
Yes.
load.
Yeah,
it's a great question.
So we've got Mattrack. Not sure if you know of Mattrack. They are a company that, I think Mattrack stands for materials tracking, but basically what they do is they work with companies like Lend-Lease and facade contractors to, initially what their business model was set up upon was tracking materials order, shipments, defects, reorders, and reshipping, to kind of understand where materials were coming and going, and how that, to kind of make that more efficient. But they now also realize that having more, it's easy to embed more information into their software and database, so you can track the exact alloy of aluminium that's used. You can track the embodied carbon from a thing, so that when it comes time for a facade to be disassembled or to be refurbished, they know, or indeed recycled at the end of its life, they know what particular alloy it is, and it can be sent to the correct stream much more easily and effectively. So yeah, they're currently doing a case study as part of the working group on that.
I think that's part of it. I mean, surely the use of anodizing, and we all know the issues associated with getting anodizing on a curtain wall and all the obstacles. But though, and the use of sealants in the sticking the framing together and holding the glass, and those are issues that need to be overcome at some point. To the Michael's point about recycling. But to me, the current barrier to anodizing from it might get scratched. To me, that's crazy.
Yeah.
Like
this is
recorded. Something we can overcome.
Pete, this is recorded, by the way, right?
No, I get that, but it's an obstacle that comes up on every single job where we try to get anodizing from a circularity. We get the same obstacles, which I get it.
What are those obstacles?
Well, the usual one. So there's two of them. One is if it gets scratched, its perception is difficult to touch up, and it's true.
Yep.
And then the other one is the quality of anodizing coming out of China is very poor, because the energy supply in China is very poor, or it's very erratic. Let's say, the delivery of current is not smooth in China.
Yeah.
And so then the quality of the finish, or the variation in color is very high.
100%. Yeah. There's a third element to that, which is often overlooked, and I often use an analogy, like if you've ever bought a cedar door, and you look at the bottom part of the door and the vertical parts of the door, they can often be a very different shade of timber. Anodizing.
Yeah, no, that's true. That's true. Yeah.
Anodizing behaves in a very similar way. The wall thickness of the extrusion, the density of the junction where a web might come together with a wall in an extrusion. All of those things, along with things what we call carbon lines or flow lines, which are the drag lines through the extrusion die, all of those things play a role in producing a piece of aluminium that, when it goes into an anodizing bath, it comes out with shade variation and lines, what we call flow lines or carbon lines. So, those things are almost unavoidable. People try to put 25 30 thinking the deeper of the micron of the anodizing will get rid of those flow lines or carbon lines or shade variations. But the reality is that anodizing is a controlled corrosion of the metal to give it a surface protection, and essentially you're seeing the bare bones of the aluminium. So we even have that problem in Australia with anodizing, getting that consistency.
And the less we anodize, the lazier the design gets to try to design for that, with keeping equal wall thicknesses and those transitions. And as we move away from that, everyone forgets how to design for it. So you have someone snap back and do an anodized job and don't do it correctly, then it's going to become a disaster precedent that everyone will be scared of.
Yeah, and if we made the wall thicknesses the same all the way around, we'd never sell it.
Yeah. But I mean, without getting into
getting
into the weeds of anodizing production issues, I suggest it's one that it needs all parties to buy into, in the same way that using, lower embodied carbon aluminium, it needs everybody to buy into and accept the issues that go with it.
Well, yeah, anodise it's not a very environmentally friendly process, anodising, when you consider the chemicals and the electricity that's required to do it. I mean, a warranty grade powder coat would be my option every day.
Isn't it also very toxic for the people who are doing the anodizing?
Yes, whereas powder coat is moved to non-chromate pre-treatments these days, so powder coat is a lot safer than the anodizing. Yes, 100%.
I'm really happy to hear all of the fantastic discussion and debate. I'm really happy there's not just, well, yeah, unfortunately we probably do have to move on, but just to make sure we get through it, but happy, with all the time remaining to keep the conversation going. But it's really great to hear the level of interest. So the next bit is really focusing around the shift in Australia. I think this has certainly been a market increase in media coverage, over the past year that I've certainly seen, from announcements between Capral and Tomago Aluminium on Australia's leading recycling agreement, to the federal state ministers visiting key smelting plants, signaling a shift in the government's importance on climate issues, to research initiatives from leading circular economy consultants and our own working group members, Corio, on Australia's vast potential for a low carbon and circular future in aluminium. But really not all of this is new. Rio Tinto's Bell Bay smelter in Tasmania and New Zealand smelter on the South Island have both run predominantly on hydroelectricity for many, many years now, and offer a local low carbon option for aluminium if you can get your hands on it. Also, Tomago Aluminium, Australia's largest smelter, owned by a consortium including Rio Tinto Alcan, Gove Aluminium and Hydro Aluminium, just up in the Hunter Valley, has recently committed to running fully on renewables by 2029. They're currently out to market for proposals, and will play a key role in the Hunter region's transition away from coal to more sustainable technologies. And finally, Rio Tinto has also just recently announced plans to develop over 4 gigawatts of diversified renewable energy supplies and technologies to its Boyne smelter up in the Gladstone region in Queensland. So safe to say, I think there's really a lot happening in this space. Well, I was going to say I'd like to introduce you to Michael O'Keefe, but we've already kind of made that introduction. So Michael is the general manager in marketing technology at Capral, and will take us through some of their own recent developments. Michael, I'm happy to hold on this slide here just to give you the opportunity to explain a little bit about who Capral are, and before we move on to the next slides, if you like.
Yep, thank you, Jeff, and good afternoon, everybody. I've already been speaking a little bit about that. You heard me. I get an interest in that space of anodizing, but I'll move on to what Capral's doing. And I was very buoyed to see those slides a moment ago there with the investment going on in Boyne and Tomago, because it's certainly a journey that Capral, as one of Australia's biggest extruders, has to go on. About 2 years ago, Capral embarked upon its sustainability roadmap, and we did it for a number of reasons. We did it because we believe that Capral had to change some of its internal behaviour as Australia's biggest extruder, having 8 extrusion presses right across the national footprint of Australia. We consume considerable amounts of Scope 1 and Scope 2 emissions. But additionally, we wanted to have a behavioural shift inside our organisation. So we commenced a sustainability roadmap that changes our behaviour in energy consumption, in waste reduction, in sustainable procurement, which is what this afternoon's a little bit about, and also in recycling, around our circular economy and what we can do in the way of our packaging and things like that, from a reuse and repurpose perspective. So when we set about this particular roadmap, we looked to some of the industry and world leading bodies, and obviously the Aluminium Stewardship Initiative that everybody is no doubt aware of, is a world body that charters the sustainable procurement and manufacturing of aluminium. So Capral is now a member of ASI, and we're in the process of becoming accredited to both the performance standard and the chain of custody standard, which helps us along this particular journey. So we have a large specification team that operates all around Australia, spending their days in architectural firms, and the resounding message was, what are we doing about not just recycled content, what are we doing about the whole sustainable supply chain? Recycled content was the biggie that they first started to talk to us about. But as you'll soon see and heard from Jeff, that recycled aluminium in Australia is not really dealt with as we would probably like it to see. 95% of recycled aluminium currently goes overseas, and a very small portion stays on shore. So we ventured into a partnership with Tomago last year and earlier this year, where we now send them 550 tonnes of production scrap. So that's post-production scrap that I spoke about before. That's directly off of our screws and presses. This particular 550 tonne comes from our Penrith press, for those of you that are in New South Wales, out at the base of the mountains. And so the primary aluminium comes from Tomago. It then goes back to Tomago in a baled 550 tonne containerized shipment, and Tomago remelt that and put that back into cast billet, which we don't necessarily get back. That cast billet goes back into the market and could go to any extruder that's using that particular log that they're purchasing from Tomago. But it's a significant step for Capral in moving towards a circular economy when it comes to aluminium, and we're now negotiating to take that even further as the years go on to increase the recycled content into everybody's metal, not just our own metal. So, thanks, Jeff. Followed by that, we've been working on this particular press release, which came out on the 1st of November, I think Tuesday gone, a week ago. And that was Capral now offers low-cal aluminium. And this came out of an initiative that during the pandemic, we had a lot of inquiry around locally manufactured, not just necessarily locally low carbon content, but locally manufactured. So Capral is really proud to introduce to the industry two market offerings known as low-cal. And for those that want to know what the 13 is at the bottom of the table, that's the periodic table number 13 for aluminium, which I'm sure everybody knows, but just for the curious. So the two products we now have on the market that are available are low-cal green, where all of the aluminium that produces the window and door systems, curtain wall systems, architectural glazing systems that Capral supplies to the Australian marketplace is in low-cal green, where the aluminium is coming from a certified smelter, ASI certified smelter, and it has a emission of CO2 of 8 kilograms per 1 kilogram of aluminium, or 8 tonnes per 1 tonne of aluminium. And then you have the opportunity to purchase for your projects or specify for your projects low-cal super green, which again is billet, primary billet, no recycled content, coming from a certified ASI smelter at 4 kilograms or 4 tonnes of CO2 emissions per tonne of aluminium. You can see there on the bottom that Jeff showed that number of, I think Jeff just had 14 up through to 20, which captures a lot of the smelters around the globe. The global average, as reported by the International Aluminium Institute, is 16.8 kilograms. So some of the conversation this afternoon, I guess, is really going to open some eyes, because the vast majority of the aluminium that's going into our windows and doors in Australia is carrying a significant content of CO2 emissions, which is why Capral has taken this step to offer the market, particularly the architectural window and door market, which is where we're offering this product first and foremost at no premium. Interestingly, for those that were considering for the architectural window and door market, low-cal green is at no premium. So that tends to pick up that comment that Jeff was bringing on earlier on, that when Lend-Lease did their due diligence on the project, they found that the actual primary aluminium input has a very little, if no, cost imposed upon the project. Certainly the labour of having it manufactured offshore can certainly change the balance of the equation, but the primary aluminium input is negligible. So that's where we're going, and obviously with any good initiative that you want to put across a wide industry, you've got to have a significant underpinning authority that allows you to do this, and Capral now subscribes to the chain of custody processes of the ASI standard, and we now have full responsible and green sourcing of our aluminium in accordance with the ASI performance standard. Thank you, Jeff.
Thanks, Michael. That's really exciting news for I think the construction industry here in Australia. And thanks very much for your and Capral's commitment to advancing our low carbon future. I think this is again probably a good time just to open it up to the floor to see if there's any questions for Michael about that.
Where's your smelter, Michael? Where are you getting all of this really low intensity carbon power from?
Unfortunately, not from in Australia at this point in time, as much as we'd love to be buying low embodied Scope 1 and Scope 2 emissions aluminium log from Australia. Unfortunately, at this point in time, we're procuring it from overseas. So we're getting it from both hydro power fired smelters, and additionally, we're getting it from gas fired smelters as well. So whilst we acknowledge that the gas-fired smelter is a fossil fuel-fired smelter, it is 50% more efficient or 50% greener in its embodied carbon content than coal-fired. So the 8 kilograms or the 8 tons is gas-fired, and the 4 tons or 4 kilograms per 1 kilogram of aluminium is hydro-powered.
So, Michael, does that that calculation on embodied carbon include the additional transport? Then that's all been factored in, or is that just the production carbon?
No, that's just the Scope 1 and Scope 2 of the smelting process, which is the way currently the international industries bodies measure CO2 emissions within aluminium. They deal with the smelting process of Scope 1 and Scope 2. The Scope 3 emissions of mining and refining, and some of the transport emissions of Scope 3 downstream through supply chain, total approximately global average about 2.3 across the board. Mining is about 0.3 of a tonne per tonne of aluminium, and refining is about 1.8 tonnes per tonne of aluminium, whereas smelting can be up to 16 or 20. So we're sort of cooking where the heat is, if you like.
Also, just I mean, because I'll certainly be looking to push specification of these windows, because we do have a problem with window frames, as you know. But is it available across the full range, so including the thermally broken and thermally enhanced suites?
Yes. Any of Capral's architectural proprietary window door systems. So that's from our curtain wall systems, 175mm curtain wall systems that'll do any of the high-rise buildings in the CBD, right down to the residential windows that you might get for the renovation of your house. All of those proprietary suites, just to rattle them off quickly, not to pitch, Jeff, but the Urban Plus, the AGS Commercial, the Future Line thermally broken, or the Schuko products that Capral distributes to the market, particularly the Schuko products that we extrude in Australia, not the Schuko products that we import. All of those carry the low-cal badge and certification if required, and ASI certification if required, at no premium.
Excellent, thanks.
So please specify it in your projects.
Is the 8 kilograms of CO2, is that proposed as a standard, or is that something you have to ask for to specify?
That's a standard with Capral window door systems. That's a standard. If you would require the super green, which is the hydro powered, so the 4 tons, that would be a special request, because we would be required to internally manage that process to ensure that particular log was utilised.
And is there a big percentage-wise cost increase for that?
The super green is 50 cents a kilogram more than your standard aluminium. So I guess that probably goes to a good question we're having there before about China. If you had a building that was 50 cents a kilogram, so we're talking $50 a ton. If that was a 20-ton building, 5 2s are 10. You know, you're talking what, $10,000 difference. That's it. Yep. You're talking, negligible difference in the cost of the aluminium.
Anyone else before we go on to the next section?
Just
talk
from
Yeah,
one
sure,
final
Paul.
thing, you're not going to tell us where overseas that we're getting this from, or we're going to leave it just at overseas, Michael, or going to be it?
I'll have to leave it overseas at the moment because I think I saw an Alspec badge up there on the thing there before.
Remember, sharing is caring. We're all in this together.
I'll have one of my specifications come to your office and they'd be more
Thanks
than
very
happy
much.
to share that information with you.
Okay. Now we'll talk
I
a
will
little
just
bit.
say though, Jeff,
yeah.
just in closing for that question, I wasn't trying to be smart. We've spent a lot of years refining our procurement and our responsible procurement processes with those suppliers of billet, and we continue to refine that and order more and more every year. So Capital intends to increase the number of tonnes that it has available to the market, being that we're a 65,000 tonne organisation. We don't have 65,000 tonnes of locale, which is why it only is currently going to our window systems. We want to move it into marine and transport and all our other industrial parts of our business. So we've been a little bit cagey as to where it's coming from at this stage. So I'm sure you can understand that.
That's actually probably a pretty good segue to the next slide around procurement. I think all of us on the call today certainly have an understanding that aluminium is used in lots of different applications. I guess in the construction sector. So while many of us have experience in large-scale commercial facades, it's also important to know that aluminium is used extensively in residential door and window systems, louver systems, and something we probably don't think of too often, but also as the support framing systems for many of our cladding materials, like terracotta, fiber cement, porcelain, or GRC, rain screen cladding panels. These are kind of all opportunities where, when we're looking to specify those systems or products, understanding that there's an opportunity potentially in that aluminium as a kind of secondary product to consider.
Jeff, can I throw one in there just quickly?
Yeah.
Just for a little bit of anecdote, the current importation into Australia of solar rail from Asia is 30,000 tonnes. That's how much solar rail is coming into the country. So, yes, aluminium is used in an amazing number of locations, and all currently has poor carbon content.
So suppose, leading to another question, I wanted to highlight a few other points to help frame it. This graph looks at the carbon intensities of aluminium expressed in tons of CO2 per ton of aluminium. As you can see, China currently has some of the most carbon intensive aluminium on average, between 17 to 20 tons. I would just note the little question mark around 4 there, and I'll touch on that here shortly. Not too far behind that is Australia's average, between 14 to 15.5 tons, compared to a global average of around 12. Again, depending on where your sources are.
Yeah.
These four scenarios to the right of the graph represent aluminium produced using renewable energies and varying percentages of recycled concrete, with the global average, as Michael was talking about, around 4 tons of carbon dioxide for every ton of aluminium using hydroelectricity. So yes, low carbon aluminium does already exist, and it is here in Australia, particularly with Capral's recent announcement. These are just some of the well-known producers and products available on the market today. Peter, we were talking before about hydro. A lot of these things are available in the overseas market, but it's a lot of this product is really tied up into existing supply chain agreements, or long-standing year-on-year commitments or contracts to supply aluminium. I guess I don't really have a slide on it, but interestingly, Hydro, it's probably the world's largest manufacturer of recycled aluminium. So they've got a product called Circal. But I think something like 90 to 95% of that recycled aluminium goes into one of their own facade subsidiary companies called Wacona out of Germany. Now, Wacona also manufacture all around the world. I think they've even got an office down in Victoria. But if you're looking to purchase that product outside of their own existing supply chain, where they just feed their product to one of their own subsidiaries, it's very difficult to get your hands on it. So that's why it's really important to start these conversations early. This next graph illustrates the world's share of aluminium production, with China's 57% global share really far outweighing any other country or region. And I think the next question for us all is, do we know where our aluminium comes from? How far back in the supply chain do we have visibility? And if we don't have visibility yet, what could we do to increase that? So are these sorts of questions anything that's come up in any of your projects before? I'd just be keen to hear if any of those sorts of discussions have been happening with anyone.
On living building challenge projects, you got to know where all your materials are coming from.
What I think you and I need to do. Absolutely.
Yeah, I mean, they've come up on our projects for, I don't know, the last 10 years or something.
Oh, and aluminium.
Yeah.
All right. Can you share a little bit more? Because when we asked the same question of the facade subcontractors, it was a very blunt no. Like no one's ever asked. Yeah.
So I mean, you're probably aware of most of it. So the first time was the Barangaroo commercial towers, and that was there was an overall commitment to reduce energy by, or embodied energy by, I forget then the metric. And Lend-Lease tried to get hydro-powered aluminium, and I think they failed at that point. My memory's a bit rusty. Then you've already talked about the Tower 3 at the Renzo Piano one, and now we're doing another one with Lend-Lease with the same kind of commitments. So I assume that's kind of, if you like, the progression within one organization.
Yeah. Anyone outside of Lend-Lease having conversations with clients or contractors?
Yeah, Mervac are interested in it now. So they're another big client of ours. And I assume Stocklands, I think, are really interested. I'm not working with them on a current commercial project, but I know they're really interested in it. I'm sure someone here on the call, I think Matthew Finn's working with them, aren't you, Matt?
Yeah, I think the question of like where the aluminium comes from, I think there's a long history of knowing kind of where it's getting extruded, but where the actual billet comes from, maybe I can't say that I really know where those billets come from on my projects. And I certainly know that even when you ask the subcontractor, they'll go and they'll say, oh yeah, we know we're using this extruder, but hey, where did your billet come from? And they'll look at you blank faced. They don't really know.
Yeah, and the first step for this group would be to be asking, is that aluminium coming from an ASI certified smelter? That's the step change. If we go back to the Barangaroo Tower, and I missed the name of the gentleman that was talking there, and the Barangaroo Tower, am I correct in recalling that curtain wall eventually came out of Uwanda or someone like that?
Yeah,
that's right.
So Uwanda would struggle they would struggle to get hydro fired billet into the Southeast Asia for them to be able to extrude it. They'd have to get it extruded. They'd have to ship that log all the way down from Northern Europe to get it down to there. So they would have just said, too hard. It's going to come from a coal-fired smelter somewhere locally. So
that was pretty much how it went.
Yeah. So
I think the cost. It was the plan at the time was to bring it from Norway.
Yep.
Yeah.
And it was it's too long ago now, but it was either too hard or too expensive or not enough available or something like that.
Yeah. And all those logs operate in what we know as the London Metal Exchange, and China has its own metal exchange, the Chinese Metal Exchange, and they never meet. So to get a Norwegian log into China for extrusion would be next to near impossible. So the step change is for the developers to be insisting on ASI smelted aluminium. Then at least you must have a threshold. So ASI has a threshold of no more than 12. So you cannot supply ASI certified metal unless you can smelt it under 12 tonnes per tonne of aluminium. So that would be a step change for anybody specifying that doesn't know where their billet's coming from. They could just say, but it must be from an ASI smelter.
Sorry, just to jump in there. I am seeing work across a multitude of my clients working through their procurement organisations around where is all materials coming from, not just aluminium, and where are they coming from a second and third tier. And it's the combination of carbon, it's a combination of modern slavery and broader sustainability aspects. So they're asking the same question, but with multiple reasons why they're answering for it. So if you're not being asked for it now, I suggest it's something that's going to increase as we go through and the focus comes in.
That's a very relevant statement because ASI embraces the Sustainable Development Goals, which captures all of those things you're talking about. So that's a very powerful thing as well, because it's not just about You know, it's about modern slavery, it's about the biodiversity, and it's about the ecosystem.
Yeah,
So,
and there's a lot of and there's a lot of conversation starting, and the technology is not 100% yet, and actually it's a long way off, but around product passports.
yes.
And then the product passport and knowing the whole life cycle of the products.
So that's an EPD you're talking about?
Or potentially, but it's more of a digital product life cycle. So I don't think anybody's really landed on what the solution is. There are some blockchains coming in, but as the circular economy starts to become as a bigger focus, understanding what that product life cycle is so that you can treat it in the right way at the end of the life cycle is an emerging trend.
Absolutely.
Can I just comment on something that Matthew sort of alluded to, and sort of going back to the comment on Mycos? A lot of Australian-based fabricators now, they will place an order with a factory in China. So they don't operate the Perma-Stelisa model where they control the supply. They simply go to a factory and say, here's a design, you make it, you draw and you make it. So there's another layer in the procurement process that's been introduced over the last, I don't know, 5 to 10 years or something like that, which makes obviously a higher level of opacity in knowing where stuff really comes from.
Yeah, that's right. I mean, I think generally as a works package, the facade is probably the most complex one, or certainly one of them, much more challenging than concrete or steel. A lot of those things, made locally, not as complicated, whereas facades package may have, I think Lend-Lease was saying the facade package on Tower 3 had 50 different suppliers and subcontractors in that one thing, which is, I guess surprising, but not surprising in a way as well.
Yeah, that's a really relevant point. If you come down level to the medium to high density living, where you've got buildings that have got hundreds and hundreds of sliding doors, a lot of those big window system suppliers have actually taken their designs up to China and had them built in China and brought back in prefabricated products, because the products coming out of China for the apartment market don't comply to Australian standards, to 1170, 2047, and even to the curtain wall standard of 4824. So a lot of system suppliers like Capral will take their products to China to get them built. So they're built at a much less expensive rate, cost of labour, and then ship them back in to give to those contractors to put into the building. So that's a bit of a sad indictment that we've had to end up in that particular position, but that happens a lot as well.
Okay, I might move on to kind of probably more or less the final session, but I thought it's probably worth touching on this. Now, Michael kind of talked about it a bit before, but I think, this is kind of, I guess in a way, not all doom and gloom, and we certainly don't want to be singling out China kind of in this scenario, but I think we're all aware of the role that, as we're discussing, that China currently plays, just not only in the production of aluminium, but also obviously in the manufacture of facades. Thinking back to the graph that I showed earlier on the average carbon intensity of aluminium by country or region, China was at that top of the list for a reason, and that is currently that as Michael alluded to, over 80% of the aluminium produced in China uses coal-fired power, many of which are captive coal plants just for the smelting plant or plants in that particular region. However, the Chinese government, you may be aware, has certainly understood the impact that their coal power stations have on the climate, and their own environment, and have sought to move a significant portion of their smelters from to southern regions or where hydroelectricity is in much greater abundance. So this is something that's already happened. I think over the past decade, they've relocated I think upwards of 20 different smelters from the kind of more northern regions where the hydroelectricity is not as available down to the south and sort of western regions. I think the point is being that there are options for lower carbon aluminium in China or wherever you may procure your aluminium facades from. It's just having the time and I guess the tenacity to kind of ask the right questions.
Yep.
So
Jeff, add to that, the very pleasing thing in that space, if you just go back a slide, the other very, very pleasing thing is China's also investing hundreds of millions of dollars at the moment into advanced remelt facilities, because they see the end of life cycle consumer aluminium becoming enormous with their construction. So they are seeing huge recycle opportunities, and to their credit, they're investing considerable amounts of money into remelt and recycling strategies. So that's another real good thing for us, because we get so much product out of there.
Absolutely. So as just one example, there's a consultancy firm called Wood & Mackenzie. They produce a series of asset reports on nearly all of the Chinese aluminium smelters that outline their ownership structure, their power supply source, and their annual out capacity, amongst many other things. And as highlighted on this slide, this single report identifies a region of smelters operating on hydroelectricity that produce over 3.1 million tons of aluminium per annum. So when you compare that with Australia's total production per annum of 1.6 million tons, 90% of which we export, I think you can see that if we ask the right questions or look in the right places, or speak to the right people, there is an opportunity to find a solution. And as we've been discussing, part of this discussion is not just about embodied carbon or cost, but about more broader issues around our very complex and global supply chains. It's not just the things that go into our buildings, but I'm sure very few of us are actually aware of where our things come from. So the impact that they have on the environment and the people that are involved in the supply chain, I think we're really just starting to have a much greater understanding. We may have touched on it a bit, but I guess I'll just ask it again, to the group. How are we addressing modern slavery in our own businesses and projects? Is this something that you think is discussed with our projects and clients, be they developers or contractors? And possibly how seriously do you think this weighs in the tender process? I'll leave it there for any feedback.
Well, all I can contribute is that BuildCorp are very active in their procurement of sending everyone big questionnaires relating to modern slavery, but that's the only one I've seen so far.
Still just a questionnaire, though, isn't it? It's just like
well, what they're acting in the back,
claim.
you don't know, of course. Yeah, of course. Yeah, no, I appreciate that.
Yeah, and that was what the feedback was from the builders as well. It's just like it's a declaration to say that you're not there is no modern slavery or anything, but beyond that, is there much happening?
Yeah.
I think it's like material procurement. You don't really know what's going on overseas in a factory making whatever it is.
Exactly.
Or digging stuff out the ground. You've got it's so many layers removed. It's impossible. Well, I say impossible. It's very difficult to know what's really going on.
Yeah,
and that's
the solar panels is a great example, isn't it? You buy your Chinese solar panels. They're probably made in Xinjiang or whatever that province is called, and you have to do a bit of due diligence to be certain where they're coming from.
And that is the real power of the Aluminium Stewardship Initiative, that they certify all those sorts of operations, from the mining to the refinement to the smelting. So there is kind of transparency in that standard if you're able to source a certified organization or from a certified supplier.
Yep. And you're audited every 4 years to ensure that you maintain compliance in all those areas. So we're just going through that at the moment, and one of the main criteria they've given us is consultation with First Nations people to ensure that we haven't adversely affected any of the surrounding areas to our facilities in relation to our Indigenous people. So it's ASI is very, very strong in this area.
Okay, I'll move on. We've already touched on this, so I will just be very brief. The funny story was, I guess, from the last session where with the facade and main contractors, I invited everyone to unmute themselves and have a chuckle at the architect telling them that how much something cost, which they all took the opportunity to do. But I'll just kind of touch on these two slides here. So as Michael said, all aluminium, like metals, is traded on the market per ton. This graph shows the fluctuation in price per ton over the past year to date. So ranging from just under, I think, $2,250 to upwards of about $3,750. Obviously, this past year has been quite a volatile one. And as you can see in the quote from a recent article looking at price premiums between purchasers and suppliers, an average of about $30 per ton or more was the expected premium to pay. That article in the detail did say anywhere from 10 to about 50, which I think is very similar to what Michael was talking about earlier. So interestingly, that really just represents a 1 to 2% uplift on the base cost of the raw material, which backs up what we've heard from Lendlease and Capra earlier. So now that I'm sure it's not just as simple as like, saying to our next client, this stuff doesn't cost any more. But I think the important thing is to make sure that, it's kind of giving us the ammunition or the information to go forward and help educate our clients and the people that we're working with to say, look, I understand, the question, you're getting this feedback, but I think we need to push a bit deeper, ask a bit more. Okay, so now to kind of wrap things up, got about 15 minutes left. I think we're probably doing all right for time. So I guess that, what can we do as architects, facade and ESD consultants, what is our role in helping to bring about a low carbon future in aluminium? I personally think that the first thing to do is really to help bust some of the myths that are out there. Some of the questions that I've heard from clients around some of the technical aspects of low carbon aluminium, things like, does it have the same performance as, quote unquote, regular or virgin aluminium? And the simple answer is really yes. As I think Michael talked before, low carbon primary or virgin aluminium really just means that it was likely produced using hydroelectricity or another renewable energy source instead of gas. So it is the technical equivalent of its counterparts. The other question that I've been asked quite a few times, again, is around the performance of recycled aluminium compared, again, to its primary counterpart. And again, the answer is yes. So if that recycled aluminium is certified as a particular alloy, it will have the same properties and characteristics and performance as its primary counterpart. So, for example, if you're specifying a particular alloy such as 6060, yeah, that alloy will perform the same. So the challenge then is that currently, and I think we were discussing this before, currently recycled aluminium is much less available in the market, but I do think that will change in the next 5 to 10 years for the reasons we were discussing. And the final myth is what we've just been talking about earlier, that low carbon aluminium really is not cost prohibitive. We just need to have the persistence to keep asking questions of our supply chains to unlock those opportunities. And I think as consultants, we sit in a unique place, often working both for owners and developers, but also innovative contracts for our contractors. I think a lot of what we can do is about advocacy and education on both sides, and starting this conversation early. This will help create a strong demand signal to the market. And I think the more people asking questions, pushing clients and supply chains, understanding where our stuff comes from, the more quickly we'll be able to bring about this change. I think more specifically, how can we start to specify or nominate low carbon aluminium in our specifications? Maybe just pause here to see if there's any kind of thoughts from the group on that. Really, any thoughts or questions from the group on this last section, as it was really the key kind of takeaway from us all for today. So any thoughts or questions on some of those key takeaways?
Question I have for Michael. It's Hugh Keithley from WSP asking these questions. Michael, if I specify your green aluminium, would that cover all of your alloys from the lowest strength that I need to the high strength alloys that I would need in anchor clips and the like?
I'd have to take that one on notice, because it would also determine on what size extrusion, whether it has to go through a 10-inch press or a 7 or an 8-inch press. So predominantly all the architectural alloys, the 6060 and the structural versions of those alloys, the answer to your question is yes. But if we got into some of maybe the more complex alloys, then I'd have to have a look at it and see.
Yeah, like a high strength 6061.
Yeah, 6061's okay. We've got 6061 log. It's just a structural 6060. So yep, we can do that for you.
Mm-hmm.
So we use some of those structural alloys in our 175 curtain wall and some of the areas I think you're talking about. So.
Okay, thank you.
Anyone else?
I was going to say it might not be relevant to aluminium and the embodied carbon in aluminium, but just reducing the amount of aluminium we use by creating thinner curtain walls, more efficient curtain walls, making sure that we use our aluminium smartly and don't just build thick 200 chunky frames.
No, absolutely. That was actually a MECLA session on that pre-design strategies. I don't know if anyone attended that, but it was all those sorts of things that we can do as designers. Pre-design, or I guess it did evolve into design, but doing less. And I think that is a challenge around lots of some of the other cladding systems. If you look at terracotta, well, all that terracotta is held up by aluminium rails. So how can we kind of capture that or understand what the embodied carbon content of that is, or what are the opportunities? Because a lot of them, to my understanding, the terracotta may be made overseas, or the cement panel may be made overseas, but the actual rail fixing systems are engineered and designed and made here in Australia.
Yeah, it's a very good point, and most or all of the big system houses have to start looking at that circularity by design. Whereas we supply metal to these fabricators at 6.5 meters long, and sometimes they'll throw away 2.5 meters because they can't use it in another window, because one's an awning or one's a double hung or one's a curtain wall. That whole circularity by design has to start to come into play, where the yield out of the aluminium that's used to make a building is much higher with much less waste. So it's a very important point. And capital, not to Sky Capitals, but they're all doing it. The Alspecs, the AWSs, all the big system houses are now looking at that to get a better utilization or a cross-pollination out of their designs across multiple types of windows in their systems. It's another way of reducing, to your point, the amount of aluminium that's actually used to make a building.
Well, I'd like to say that takes some more design effort up front, which
certainly does.
A lot of clients don't want to pay for. They just want to grab what's off the shelf quick and easy.
Yeah, I think we've got to do it, Hugh. We've got to do it before that. We've got to do it back in our design offices, back in our R&D offices, where we're delivering new curtain walls to the market. We've got to make sure that the same shape can be used in multiple applications to just give those efficiencies. So it's not necessarily, it's about us doing it smarter in-house when the market, before we bring designs to the market.
Well, I think consultants speaking for other consultants, we'd love to be a part of that. Would like to be a part of that as well. Yeah. We tend to be cut out of it by the time we're employed on the job.
Yeah, you're dead right. And then what happens is you give us a design that you want that's bespoke for the project, and that becomes an additional one you have to make because you weren't there at the beginning. That's a very good point.
I guess for me, the biggest kind of thing to take away out of all of this is really that, at least in my experience, and I assume it may be very similar for everyone else on the call, but when we talk about embodied carbon, and that conversation generally is really just kind of emerging here more recently in Australia. Everyone's talking about concrete and steel and a few other bits and pieces around, but I think the conversation around aluminium really is only just beginning. So I think really, like I said, this is about education and advocacy. So hopefully some of what you've learned today will help give you some of the tools. I encourage you all to kind of download the document, the 10-pager that's available from the MECLA website, and kind of go forward and have more conversations with our clients and contractors. I might just wrap up then, and depending on how I go, if I can whip through this, we'll just wrap it up with any final thoughts or questions. But I'd like to end on something called For What It's Worth. Hopefully, this kind of puts a lot of what we've been discussing today into another light and makes us really think again about the impacts of what we do. So, For What It's Worth is the title of a series of artworks created by South African photographer Dylan Marsh. Dylan's work often looks at the impact that man has left on landscapes in his home country, including abandoned mining towns and mines. The series of artworks illustrates the volume of material extracted from a particular mine, such as diamond, gold, platinum, or copper mines, as shown on the next slide. So what Dylan does is he photographs these places and he researches the amount of material extracted from that particular mine, and with the help of a visualizer, inserts a visual representation of that mine material. And that really, I guess, got me thinking about aluminium. So aluminium is made by mining bauxite, and as I mentioned earlier, Australia operates the world's largest bauxite mine. You know, it's scraped up from the earth, usually in surface mines like this, put into enormous trucks like this, which this is a very non-technical presentation, by the way, but just remember this truck. You know, it's processed by big bloody machines like this and scooped up and dumped onto trains, carried, you know, hundreds of kilometers to the port where, like I said before, we export 90 to 95% of our bauxite overseas. And so Australia has the world's largest bauxite mine in the Northern Territory in Weipa, Australia. So if you start to zoom into this box, you can start to see the impact that this mine is having on the natural landscape. You know, kind of, I should have pointed it out earlier, but we're kind of looking up here at the northern tip. Zooming in yet again, you can start to see the kind of the vastness of the operations and mines here. Zooming in yet again, we get another photo, and if we were to have enough higher resolution zooming in here, you'd see that this small dot within that box is actually one of these trucks, and I think that really just kind of gives you the vastness and scale of the impact of these things. You know, these operations that kind of go into creating the materials that we all use. And it really makes you think, so, you know, the next time we have one of these, or we might work together on one of these, I would ask us all to remember what it's worth. So that's really all I have for today. If there's any more final questions in the next 5 minutes, I'm happy to open it up to the floor, and otherwise I'm happy to leave it there. Nope. Okay.
Jeff, I'll just add.
Yeah, sure.
I read the 10-page one. I thought it was really great, really succinct, and it ends on a really quite a compelling point to say that we should be looking for demonstration projects wherever we work. So wherever we interface in our professional lives as consultants, that we're constantly on alert for opportunities. I think that's early conversations are the best way to start.
Absolutely. I mean, the power of demonstration projects is, you know, doing something for the first time. So obviously the Lend-Lease Tower 3 is one to say that, look, this is possible. We're certainly looking at it on another of other projects, but I think it's just really about, you know, again, educating the market, demonstrating to clients that these things can be done. Yeah. So, you know, if you have any thoughts
Getting
about
the
opportunities,
demand signal as well, I think, to suppliers, etc.
Yep. And I think that's something that Capral's done really well, is they, you know, they were on this journey. You know, I would say, Michael, before you joined MECLA, but saw it obviously as an opportunity, and we're really pushing, you know, myself and the other group members to understand, you know, what those challenges and opportunities were. And I think, you know, some of the recent announcements just over the past few months have been really, really welcomed by the group.
Oh, I think MECLA opened our eyes to how important this is going forward. So yeah, we were on the journey first, but certainly once we joined MECLA, we've really put the foot on the accelerator because we see how important it is for the industry.
Fantastic. Anyone else? Hey,
I'll just kind of make a sort of comment, really, that, you know, it's great to see Capral develop their process and allow procurement from Australia. Getting to grips with the Chinese equivalent that's probably a challenge we've all got to get our head round, because you know, only it'd be great to see a lot more material being manufactured, you know, produced and manufactured in Australia and recycled and reused, and, you know, the whole circular economy within Australia. And that, you know, but I think and that might be a longer term objective, like to really shift industry. In the shorter term, we probably have to deal with sort of Chinese equivalent of that as well. It'd be, important to think that one through.
Yeah,
I'm
love the
stating the
sentiment.
obvious.
Love the sentiment. Love the sentiment. You know, if we could rebuild the Australian contractor base to service the construction industry with locally produced low carbon aluminium, that would be panacea, wouldn't it? But I think you're dead right. In the first instance, we know Asia's just up the road. We know Indonesia and Thailand and China are just up the road, and we know they produce good product. We just have to influence them to use greener product.
I think that's part of the next deep dive as well, talking with the purchasers and owners and developers.
Yeah,
Just like, you know, their supply chains, what are they doing to start to influence them and change the way that they procure things now, and what can we do to drive change there?
Yeah, because I mean, the reality is Capral is probably one of the biggest system suppliers in Australia, but we would have but a handful of customers that would be prepared to go into the high-rise construction curtain wall market, because they've been driven out of that market over the last 15 years for lots of reasons. But you know, that's the domain of Asia at the moment. So, you know, we have to embrace that and make them greener, to repeat myself.
Monica, you were going to mention something?
No, I just wanted to share with you, Jeff, as a result, I was in Melbourne yesterday talking to the City of Melbourne folks, and as a result of your last Spotlight event, one of the staff members was listening in on the imminent recyclability of aluminium, and they, you know, they're hosting the Commonwealth Games in a couple of years, and they said to Coca-Cola recently, instead of supplying Coca-Cola in plastic bottles, please only use cans, aluminium cans, because we know that they can be put back into the aluminium cycle for manufacture. So, you know, it's really those little steps and those little conversations that you never know where it goes, but it does have that ripple effect.
Yeah, absolutely.
Okay, well, bang on 3 o'clock. Really happy that so many of you were able to attend today. Really happy that, you know, the invite was shared around, you know, colleagues internally and externally. So thanks very much everyone for your time today. And you know, if you have any questions, please feel free to reach out, and thanks again.